Hi everybody, very good evening. Hello. Quickly let me know if I am audible and visible, guys. Hi. Just a second, let me just set it up. Hi Nina, very good. Good morning. Good evening. Good evening. Good evening. Yes. All right. So as always, like I always say, Andiriki Namaskaram, Ellargu Swagatam. This is me, your master teacher Nabamita Bhattacharya, and today we are here for the part 2 of states of matter. And today we are going to finish a lot of important topics and a lot of important concepts, things that actually do come in your JEE exam. Yes, so do not go anywhere. Stick till the end of the session. We will be solving a lot of questions and everything. Yes, you just don't have to go anywhere. All right, everybody. Yes, so shall we start? Shall we start? Thank you so much, Ram. Thank you so much. So quickly go and call up your friends and let us start with the session. What do you all say? Are you all with me, everybody? Yes. Are you all with me? Yes or no, guys? Are you all with me? Quickly go and call up your friends and let us start with the session. I'll just give you 1 or 2 minutes so that you can quickly go ahead and call up your, you know, let me just quickly give you a little bit time so that all of you can come up. Yeah. Good evening, Bachus. Good evening. Okay. Also, let us give you a quick recap of what are the things that we studied in the last session. Yeah. In the yesterday's session, yesterday was states of matter part 1. And in the yesterday's session, my dear Bachus, we studied about the states of matter. Basically, what do we have? We have solid, we have liquid, and we have gas, right? Yes, these are the 3 states of matter that we actually know from a very young class, isn't it? When we were in our 4th or 5th standard, from that time we know that there is solid, there is liquid, and there is gas, isn't it? Yes. Then we learned a little bit of their properties. Then we spoke about a little higher order properties like attractive force, thermal motion, volume, geometry. Yes, we in detailed manner we learnt about the intermolecular forces, the London forces, dipole forces, dipole induced dipole forces. We spoke about the how the force is going to differ in each case. Like force is mostly 1 divided by r to the power 6 or 1 divided by d to the power 6. However, in certain situation, like for example, in dipole force, yes, in dipole force for a stationary polar molecule, yes, the force becomes 1 by d to the power 3. Okay. No, aim good. You are here right on time. You're here right on time. I'm just doing a recap here. Okay. This is 1 by d to the power 3. This is what we studied yesterday. In the yesterday session, we have spoken about this, isn't it? Then we spoke that when we are talking about the behavior of the gaseous state, of course, there are certain measurable quantities. The quantities that you can measure and you can come up with laws. What were the measurable quantities? The measurable quantities that we spoke about were everybody mass, pressure, temperature, volume. And based on that, what we did was we kept mass and temperature constant and we found a law. We kept mass and pressure constant, we found a law. We kept mass and volume constant, we found a law, right? So when we kept varying these things and we kept coming up with newer laws, like what were the laws? There were Boyle's law, there was Boyle's law, there was Charles' law, there was Gay-Lussac's law, there was Avogadro law, and combining all of these, we came to a conclusion where we came up with something called as PV is equal to nRT, if you remember. Yes, we have spoken about that also. This is just a recap, quick recap. I'm going through all of these things, everybody. Yes, I taught you all of these. If you haven't been there, then what you need to do is quickly go and watch yesterday's session, everybody, so that you are crystal clear. We also solved a lot of problems here, okay? We also solved a lot of problems, and this is where I ended the session. After the ideal gas scenario, I ended the session, okay? Now, today we are going to start with this question. But before I start with the session, everybody, let me bring you the new slide. Yes, because I have done some editing here. So just a minute, everybody. Yeah, just a minute, everyone. I have to write a lot, right? So I keep adding many slides. Which is why I'm just creating a new note, because whenever I teach you, you know that I have to write it down, isn't it? I mostly write it down on my own and then I teach you. So just a minute. Here we go. States of matter 2. Yes. All of these things were already done. Today we start from this question. Yes. So based on the prerequisite knowledge for this class, that is yesterday, whatever we have covered, from there, I am going to ask you this question. Tell me which one of the following graph is not correct for ideal gas. Okay. Now D is density, P is pressure and T is temperature. Okay. So look at the graph, everybody. The first one, okay, D and D. D is, what do we know? We know that D is equal to PM. Yes, D is equal to, yesterday you learned this, remember? What was the formula? Here. See, PM is equal to DRT. Okay, what was the formula? The formula was, everybody, PM is equal to DRT. If that is the case, then D is equal to PM divided by RT. That means D is directly proportional to pressure. D is directly proportional to the molar mass, but it is definitely inversely proportional to temperature. That means I can also write it as D is equal to 1 divided by T, right? So that means, since it is inversely proportional, so this graph is definitely right. Yes, this graph is definitely right. This is what was Charles' law, isn't it? This was the first law that we spoke about. Correct. Great. Okay. Then look at this. D and T, are they proportional? This definitely is wrong. It cannot be a straight line. No, it cannot be a straight line. We are saying that D is inversely proportional to temperature. That means this is definitely wrong. Yes, but look at this. D is directly proportional to 1 by T. That means yes, this is correct. And D is directly proportional to P. This is also correct, because look at this formula. D is equal to PM divided by RT. So all of it makes sense. Only option 2 is the wrong one, and that means that option B is our correct answer. Make sense, everybody? Yes, are we clear with this? Now are you all ready to move forward? And let's rev up our engine and let's complete the session today. Okay, today I'm going to take some time and I'm going to complete this chapter, because it is going to be a little overdose of knowledge. But be with me, everyone. Stay till the end of the class so that you can absolutely confirm the 4 marks that you are going to get from this chapter. All right. And if need be, I might even postpone my 7 o'clock class, because I want to complete this chapter. Before I do your JEE advanced session or your EMCET question, I want to be able to complete this chapter. So everybody, be with me. Today, what are the things that we are going to complete? Today, we are going to complete basically the density and the molar mass of gaseous substance, something like this that we have just covered. Yes, we're going to talk about that. Then we're going to talk about Dalton's law of partial pressure, which again you are going to learn in the chapter solutions in class 12. Right? Apart from that, what other thing are you going to learn? You are also going to learn kinetic molecular theory, okay, or kinetic theory of gases, like as we like to call it. Then you are going to learn, everybody, collision frequency and all of that. Those are going to be small bits and pieces. Maxwell's distribution, what is diffusion and effusion, and ideal gas versus real gas, how do they deviate? So these are all the things that we are going to cover, everybody, and it is very, very, very important. I cannot emphasize more on that fact. So everybody, yes, wake up, get your notebook, have a pen beside you, so that we all are able to complete the syllabus with full josh. Ready, everyone? Ready, steady, and go? Yes? Yes? Shall we? Ready, everybody? All right. So first of all, let's start with a little topic that was left from yesterday's class, right? How do we derive? How did we? This formula that we just spoke about, right? That D is equal to PM divided by RT. How did we come to this formula? Okay. How did we come to this formula? So basically, this topic will be known as the density and molar mass of gaseous substances. Okay. This is there in your NCERT. What do we say? We say that this is density and molar mass. Density and molar mass of gaseous state. All right. Yes. Okay. So now I'm going to write down the derivation so that you all are absolutely clear, because in JEE paper, you know that JEE means the questions, or in the JEE advanced, the questions that you do, they are not very tough. But what they do is the questions are asked in such a manner that they seem to be very tricky. They seem to be very tricky, which is why you go bonkers like, oh, how do I solve it? So derivation is slightly important, everybody. Look here. Have a look here, everybody. So PV is equal to nRT, right? This is the formula that we know. All right. So that means that I can write it as P is equal to N divided by V multiplied with RT, right? Yes. Now we want to make sure that in this formula we have molar mass and density. How am I going to fix this? How am I going to get to that point? So I want density, right? But do we not know that density is equal to, everybody, density is equal to mass by volume. Am I right, everybody? We all know that. And what is this N? This N can also be written as, given mass. Yes, it can be written as given mass divided by molar mass. Yes, molar mass. Can I write it like this? Can I write it like this? Yes, given mass divided by molar mass, that is equal to N. So if that is the case, everybody, for now, can I write this N equal to, this N can be written as M divided by capital M multiplied with V, and here you have RT. Am I right? And what is this M divided by V, my dear students? Density is equal to mass by volume, isn't it? Density is equal to mass by volume. I just spoke to you about this. Yes, density is equal to mass by volume. That means this M by V, for this, I can write it as a D. Yes, dRT divided by capital M. And that means that this becomes P multiplied with M is equal to dRT. So now do you get it? How we have reached to this position? And this, like we have just seen, it is very, very, very important for your numericals. Okay? It's just good to know, everybody. Yes? Now are we clear with this? Now are we all clear with this, everybody? Yes? This makes sense? Great. Okay. So now we go to a topic, okay? Now we go to our next topic, which is basically Dalton's law of pressure. Now what did Dalton say, right? What is it that Dalton said? Dalton said, everybody, that the total pressure that is exerted by a mixture of a non-reactive gas. For example, if you have a container, and in that container, let's just say that you have a gas A and you have gas B. And both of these gases, they are non-reactive. They are not reacting with each other. Okay, they are not reacting to each other. So in that case, what will happen is that this non-reactive gases, yes, the pressure, the partial pressure that these non-reactive gases are exerting each individual gas, everybody. So like I said, I have a gas that is A and I have a gas that is B. So the partial pressure of A gas and partial pressure of B gas, sum of these two will be equal to total pressure. All right. You didn't get it? Let me write that down, everybody. Okay. Let me write that down here, just so that you understand. Okay. See, what did I say? I said that let's talk about Dalton's law of partial pressure. What is Dalton's law of partial pressure, everybody? Dalton's law of partial pressure is, everybody, total pressure. This is there in your book again, and this is important. Why? Because you will be learning about it in your 12th standard solution chapter as well. And in the solution chapter, we correlate it with Raoult's law. Dalton's law of partial pressure is correlated with Raoult's law, and there we have another derivation. So please do learn it right now, because it will be required for you in your 12th standard as well. Yes, and from solutions chapter, you will see another 4 marks in your JEE Mains. So total pressure, everybody. Total pressure exerted by a mixture of non-reactive gas, okay, by a mixture of non-reactive gases. Non-reactive gases is equal to the sum of partial pressures, okay, the sum of partial pressures of individual gases. All right. So that means how am I going to write it down in a numerical manner, or in a manner of equation? I'm going to write it as, check it out, P total is equal to P1 plus P2 plus P3. Let's say that we have 3 or 4 gases here. So it will keep going on and on and on like this. Okay. It will keep going on and on and on like this. But at what temperature? This will be at constant temperature and volume, my dear students. Okay. At constant T and V, we will have like this. Okay. All right, everybody. Now let's say that everybody, check it out here. Let's say that I draw a container here. Okay. Let's say that I draw a container here. Now in this container, you will have to understand that here, this is my liquid part, right? And above this liquid part, and the liquid part, by the liquid part, I mean that there is, let's say that there is some amount of water. There is some amount of water. And here is my vapor phase. Yes, this is my vapor phase. So this liquid plus the empty space that we have, in that empty space there is a gas, plus this liquid will also be converting a little bit into the water vapor, isn't it? Yes. This liquid that I have, there will be certain bit of water vapor plus the other gas as well. Am I right, everybody? So that means that the pressure that is exerted by, okay, the pressure that is exerted by saturated water vapor is called as aqueous tension. Okay. Now, if you want to find out in this container, you have to understand that if this is the liquid part, so that means that the liquid part also has some amount of vapors here. Yes. But if I want to just find out, I do not want the pressure of the water vapor. I do not want the pressure of the liquid. Yes, the liquid which is getting converted into into gas, that is also exerting some pressure. I don't want that. I want only these red particles that you see. These red particles, the pressure of the dry gas. What do I want? I want the pressure of the dry gas. How do I find it out? I will write that P of dry gas, okay, P of dry gas, just the pressure of the dry gas is actually equal to P total minus, what did I just say? Aqueous tension, okay, minus aqueous tension, the stress, the tension that is there because of this liquid. Yes, this liquid being there, it is giving us some stress, right? Yes, that how do I calculate this? So what is this? This is, you just have to subtract aqueous tension. All right. Now, let me write down what is aqueous tension as well, just so that you know, everybody. What is aqueous tension? Aqueous tension is pressure exerted by, okay. Aqueous tension is pressure exerted. I am writing the spelling of exerted wrong. Wow. Yes. Pressure exerted by saturated water vapor. By saturated water vapor is called aqueous tension. All right. Yes. Now check it out, everybody. Do you all understand this? Everybody? Yes. Great. Okay. So these are the basics of your solution chapter that you are learning right away. Okay. All right. Now what happens is, everybody, tell me something, that What if I want partial pressure? Okay, partial pressure in terms of mole fraction. Remember in that the first chapter, some basic concepts of chemistry, we learned a lot of concentration terms, right? And one of that was mole fraction, which I'm sure that everybody knows. Yes, now what we want is, we want to find out the partial pressure. Definitely, we do want to find out the partial pressure, but we want to find it in terms of mole fraction. How do we calculate the partial pressure in terms of mole fraction, everybody? Okay, let's find it out, everybody. Yes. Hey, aim God, you can't ask me questions like this. That is something that you have to solve, okay? That is something that you have to solve. I'm telling you the concept. I'll solve some PYQs, but you have to do it. Solve it on your own. You can't make me do your homework question, please. No, that's not happening. Anyway, so what I was telling you was partial pressure in terms of mole fraction, okay? Partial pressure in terms of mole fraction. How do we calculate that? All right. So we know that partial pressure, let's say that P is the total pressure, right? And we know that everybody, PV is equal to nRT, correct? PV is equal to nRT. That means P is equal to, let's say that we have A, B, C many gases. Okay, let's say that we have A, B, C many gases. So Na plus Nb plus Nc and plus dot 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 dot. Let's say that there are unlimited gases. So Nk, it goes till Nk. Okay. So nRT divided by V. Am I right, everybody? This is going to be the case, correct? This is going to be the case because what did I say? P is equal to nRT. PV is equal to nRT. So P is equal to what will happen? nRT divided by V. Am I right, everybody? Yes, exactly. All right. So we have written that. So now that means that the pressure of A, okay, the partial pressure of gas A. I just told you, right? We have A, B, C, D, E, F, J, H, many unlimited number of gases we have. The partial pressure of A gas is equal to nART by V. Make sense? Make sense? Look how we are deriving, everybody. Great. Okay. Then we go to partial pressure of B is equal to nBRT divided by V. Absolutely makes sense. What if it is for PC? PC will be NCRT divided by V. Am I right? Very good. So what will be our P total? Our P total will be basically PA plus PB plus PC and dot 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 dot. It will go on and on. Now for all of these, I can take RT by V to be common. Can I not take it RT by V to be common? So that means that Na plus Nb plus Nc multiplied with RT by V. I have taken RT by V as common. Yes, all right. Now what is happening is, let's say that I want to find PA divided by P total. If I want to find PA divided by P total, what will I have to write? I will have to write NA RT by V divided by, what is P total? P total will be Na plus Nb plus Nc dot 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 dot. Let's say that it goes up to Nk. Yes, RT divided by V, which is nothing but this. This is the P. This is the P total, right? This is the P total. So that means that RT by V here and RT by V here gets cancelled. So it will be Na divided by N total. And what is this, my dear students? What is this? This you will all agree that this is nothing but your mole fraction of gas A. What is this? This is mole fraction of gas A. Correct? This is mole fraction of gas A. Am I right? Gas A. Am I right? Very good. Very good. We have cleared up. We have cleared that doubt. Well done. Yes, we have cleared that doubt. Isn't it? Very good. All right. Now tell me something. I have another question for you. This R that we keep writing, right? So we are always writing, everybody, as you can see, we are always writing that PV is equal to nRT. Yes. What is this R? I know some of you will be like, ma'am, gas constant. But where has this gas constant come from? What is this gas constant? Why are we talking about this gas constant? And why is it just a particular number? Well, let me tell you. So R is actually, we all know that it is PV divided by T, right? R is equal to PV divided by T, right? What is P? P is your pressure. How can I write pressure? I can write pressure to be as force divided by area, isn't it? Yesterday also we spoke about it. Yesterday also we talked about it, that force that is exerted on a area, the intensity of the force is pressure. So pressure is definitely equal to force divided by area. Now what is volume? Volume, I can write it as area multiplied with length. Area multiplied with length, am I right everybody? Yes, and divided by, this is your temperature. Now tell me something, force divided by area, or force, area and area gets cancelled, force into length, what is this? Force divided by area multiplied with area into length, what is this? Don't you think that this is kind of like a work done? Yes, we are talking about work done on a particular temperature. So that means that this R that I just asked you, I have just asked you that what is this R, right? What is this R? This is your work done. Yes, work done divided by temperature, my dear students. Okay, what is this? This is work done divided by temperature. And what does this R represent? This represents work done per degree per mole. Every time you increase the temperature by 1 degree for one mole, how much work are you doing? R is the amount of work that you have to do. Yes, while you are per degree per mole. Are you understanding? Yes, are you understanding? It represents the work done per degree per mole. Every degree temperature that you increase, what is the work being done? That is your R. Okay. R is work done per degree per mole. Clear everybody? Yes. Now R has several different values, but that depends on what is the unit that is asked in your exam, everybody. Okay, what is the unit they are asking to you in the exam? That is how you have to come to the R. Okay, I think yesterday there was a certain, yes, exactly. See, if they give you joule, if they give you joule in the question, if there is a unit joule, that means that you will usually take, you will take this 8.3143. Okay, 8.3143 joule per mole per Kelvin. You will take this. Okay, you will take this. But if it is given in some other unit, then you will take 0.0821 LATM per mole per Kelvin. If it is given in calorie, okay, if it is given in calorie, which is very, the chances of giving you something in calorie unit, that is very, low. So this is something just good to know, everyone. Nobody's, probably they will not ask you a question that is related to this unit. Okay. All right, everybody. Great. Understood, everybody. Chalo. Moving on now. Moving on. Let's understand that what is diffusion and what is effusion. All right. Let's understand what is diffusion and what is effusion, everybody. And for that, I'm going to take the help of this Google slides that I prepared. Where is this? This is also done. Does anybody know what is the difference between diffusion and effusion? Chalo guys, do you see what is happening here? Do you see what is happening here? The first image that you see, you see this random movement here? Do you see like such a random movement, everybody here? Yes. This random movement, this is called as diffusion, okay? This random movement that you see, that is called as your diffusion. So diffusion is very similar to effusion. In effusion also you see random movement, but effusion is basically when the gas molecules, they escape through a pinhole. For example, let's say that I have a, I have a birthday balloon. Yes, I have a birthday balloon, and in that birthday balloon, I have just done one pinhole. The moment I have done that pinhole, what happens? The gas comes out. It comes out, right? So the molecules are still moving in a very random motion. But what is happening is from high pressure, they are going towards the low pressure. Inside the balloon, inside your birthday balloon, the pressure is very high. But outside, it is a little low, right? Outside, it is a little low. So that is why what is happening is it goes out. And that is exactly what you see in the white part. In the white image, look at it, everybody. In the white image, do you see? In the white image, what is happening? Right here, do you see there is a small opening, everybody? The moment there is a small opening, the gas molecules are coming out. See, the gas molecules are coming out of it. Do you see, everybody? Yes, getting it? Understanding, everyone? Yeah? All right. So from here, now let's write down that what is diffusion. This random motion, okay? This random motion is your diffusion. Diffusion. This is diffusion, everybody. Okay. This is diffusion. And this is your effusion. Okay. So the formula is almost similar. The formula is quite similar to each other, because in both the cases you get to see a random motion. However, in effusion, what is happening is that only difference is that it is moving out from high pressure to low pressure, right? It is moving out from high pressure to low pressure. That is exactly what is happening, and that's why we call it. Yes, absolutely right. And that is your effusion, correct? So let's write down the definition just so that it is easier and it is simple. What is diffusion, guys? Diffusion is basically spontaneous, and where do you see diffusion? Where do you see diffusion? I'm pretty sure that diffusion you all have observed or you all have experienced. For example, right now only, right in my house, I have a jasmine incense stick, agarbatti. A jasmine agarbatti is, I have lit it up and I can get the smell. I can actually get the smell of it, right? Oh, perfumes. Yes, very good, Chintala. Yes, Rajendra, very good. Perfumes. Absolutely right. So what is diffusion? Diffusion is basically spontaneous intermixing of gases. Yes, spontaneous intermixing of gas molecules or of gases. Yes, by random motion. They are always in random motion. Yes, they are always in random motion. Correct? Yes. And sometimes what happens, the molecules, they collide also. So they keep colliding, they keep moving forward. Keep colliding, they keep moving forward like this. They keep going on, right? Yes. A random motion, random motions. And let's just write that molecular collisions occur. Molecular collisions occur. Correcto, everybody? Yes, this is clear. Now let's also write down that what is effusion. Effusion, I'm writing it here. Yes, what is effusion, everybody? Effusion is escape of gas molecules through a pinhole into low pressure. Yes, but here you see that the molecules are not colliding. Why? They are just like they saw that there is an empty space. There is an empty space. So all they wanted to do was they just wanted to move out. Okay. So in effusion, what is happening is escape. All right. It is an escape of gas molecules. Escape of gas molecules through a pinhole. Through a pinhole from high pressure. From high pressure to low pressure without molecular collisions. Without molecular collisions. Yes, makes sense, everybody? Yes, makes sense, everyone? Got it? Clear? Yes, deodorants also. Very good. Deodorants too. All right. Now what happens is Graham's law of diffusion. So the process of effusion, I just told you, right? The process of effusion is actually very similar to diffusion. And same formula are applicable. Yes, you can apply the same formula with only difference is that the effusion, it occurs due to a pressure difference, which is what I told you. High pressure to low pressure, high pressure to low pressure. That is what happens in effusion. But you will be utilizing the same formula. Now, you don't have to worry about that. Hi Arjun, welcome bacha, welcome. Yes, okay. Now what happens is, see, Graham's law of diffusion, right? So we have to understand that how do we write that? Basically what we are doing is we are trying to write down the rate here. Rate. Like how are things happening? How are things changing? You know, in physics you have learned, no? Rate of change of velocity, rate of change of this, rate of change of that and all of that. Yes, something similar only we are doing here. So Graham's law is what? Rate of diffusion. Rate of diffusion only, right? How fast are they moving? Rate of diffusion. Now, I have just told you that diffusion and effusion are similar. So, we will use the same formula. Correct? Yes. Of a gas at constant pressure and temperature is inversely proportional. What is written here? It is written as inversely proportional. Inversely proportional to the square root of its molecular mass. Basically, what you can actually write it as, you can also write it as, check it out everybody. Let me move this side, yes. Good evening, Alvin. How are you, bacha? Welcome to the session, everybody. Yes. So basically, forget about all of these that is written here. Don't check it out. Right now, understand that. So rate is basically directly proportional. This is written as 1 by m. Forget about this. What did I say? I said constant pressure, right? But before that, let me write down this formula. P A divided by root over T and M. Okay. All right. Yes. Now I have just told you that let us consider pressure to be constant. But even before that, let me write down what is what. What is P? P is pressure of gas. P is pressure of gas, which is constant. Yes, which is constant. What is A? A is that hole that you made. That hole that you made, like poke in the balloon. Yes, that pinhole. Yes. So area of pinhole cross section. Area of pinhole cross section. Coolio. Yes. Then what is T? Obviously temperature. Everybody knows that. Yes. And what is M? M is basically nothing but your molecular weight or molecular mass. Now do you understand? Now do you understand, everybody? This is clear. All right. Now rate, you must have studied in physics that rate can be dx by dt. It can be rate can also be dv by dt. Rate can also be dx by dt. dN by dt, that means that how many molecules of gas escaped, right? So rate can be given to you as, everybody, rate can be given to you as dV by dt, dN by dt, that is molecules of gas escaped, or dx by dt. Now suppose in your exam you get a problem where you have to find the ratio. Then this, my dear student, yes, this right here, this thing that you see on your screen, everybody, rate of gas 1, that is R1, divided by R2 will be equal to what? Nothing. Just square root molecular mass of 2 divided by molecular mass of 1. Easy peasy. Biryani tasting. Yes. Or what you can do is take it as D2 by D1. Okay. All right. What is D? What is small d? Distance traveled by the gas. Okay. Now, if a gas is very heavy, obviously the distance traveled will be less. But if the gas is very light, it will go away. So that is why you can also you can also write it as d2 by d1 root over. Yes. So very similarly, whatever I have told you, all of this is just written on the screen. You can just have a look, everybody. Just have a look. Okay. Just have a look. Whatever I have told you till now, all of this, is it all clear? Yes. All of this, is it all clear? Guys, come on. Quickly tell me. But in this case, right, in this case, if you see, capital D is taken to be as density of gas, whereas small d, they have taken it as distance traveled by the gas. However, most of the time, we denote small d to be distance. But is everything clear, guys? I hope that the explanation is absolutely easy and you are able to understand. Yes. I hope that the explanation is easy and you are all able to understand, everybody. Correct? Okay. All right, guys. Now let's move on and let's understand this kinetic theory of postulates. Baba re, what is this that we have to learn? Okay. Now, kinetic theory. No problem, Alvin. No problem. You watch it whenever you want. Okay. You watch it whenever you want. Chalo. Achha, now we come to the fact that we have to talk about the kinetic theory of gases. Okay. In this kinetic theory of gases, what happened was, now, see, you have to understand that actually, how many gases do we have in the periodic table of elements? Although we have 118 elements, out of that maximum number of elements are actually metals and only 11 of them are gases. Only 11 of them are gases and the 118th element, as you all know, is named as OG, that is organism, right? But only 11 of them are gases. But would you really want to, like, if I was to tell you that instead of the whole gaseous state, yes, if I would have told you that, bacha, for your JEE, all the 11 gases are coming. Imagine every single gas you have to hold on to it and read about the property. You have to hold on to like nitrogen, read the property. Oxygen, read the property. Carbon, read the property. Sulfur, read the property. Won't it be too tedious? Right? And imagine that now only you have 30 to 36 chapters in chemistry. Just in chemistry, you have 30 to 36 chapters for you to be able to clear your JEE. Imagine how much the syllabus would have been if you had to include all the different 11 gases as different chapters. Just not possible, right? So the scientists and all these chemists, right, who are crazy, they thought that let's make some rules and we want the gases to be behave like that. But these are gases. Do you really think that they will believe? But we will come to that a little later. So now let's understand that what were the postulates. Yes. Now the scientists, they said that the gases, okay, the gas volume is negligible. What is the volume? The volume of the gas is negligible when compared to the volume of the container. So, for example, if I say that everybody, okay, let's say that, where am I? Let's say that in this whole room, I'm taking a class right now, in this whole room, there are gas particles. I'm breathing, isn't it? Yes. Now, when I compare the volume of the gas that is present in this room, and if I measure the volume of this whole room, it is going to be very small. The volume of the gas will be so small that it can be considered to be negligible. Okay, all right. Then we said that there is no interaction. There is no interaction between the gas particles, obviously. I mean, the gas particles, they're very far away. That is what we have studied from a very young age, that the gas particles, they're very far away. So if they are so far away, that means that there won't be much interactions. Am I right? Yes. There won't be much interactions, obviously. We get that? Everybody? Do we understand this? Very good. Okay, we said that. But see, these are wrong, right? These were postulates. We thought that this was probably right, but this was not right. We will come to that, okay? Then the gas molecules are under continuous state of motion. And what is that motion called? We all know that that is called as Brownian motion, everybody. Do you know that this is called as Brownian motion? That random movement that they are doing, that's called as Brownian motion, isn't it? Then what happens is collision with the wall of container are responsible for pressure exerted. What do the gas molecules do? They go. They do not know, right? Where is they don't know. They have no idea where the wall is. So they keep going. They hit their head and then they are like, oops, oh, that was a wall. Collision happened. So once the collision happens, and when the collision happens, what is this happening? Yes. What is this? If this is the wall and there is a collision that is happening, basically there is pressure that is being exerted, right? That is the pressure that is being exerted, isn't it? Right now, what I did, that was a force that was applied. See, when I punched my hand, what did I do? A force was applied on a certain bit of area, and that is nothing but pressure. Makes sense? Everybody? Great. Then we also know that the molecules moves with different speed. So all the molecules that are present in that container, they are not all moving with the same speed. Some of them have very high speed, some of them have very low speed, some of them are like moderately speed, right? So they have all different speeds. Speed of each molecule, it also keeps on changing as collision occurs. So sometimes what happens is, if they're just moving without anything, they will just be moving, okay? The speed will be less. The speed will be less. But let's say that they have just hit themselves on the wall, and at that point of time when they come out, the speed will be a little more, right? The speed will be a little more. Are you understanding, everybody? Yes? Getting my point, everyone? What is happening? So as the collision keeps happening, the speed also changes. Okay? All right. Now all collisions, they are considered to be perfectly elastic. What do we consider? We consider them to be perfectly elastic. Okay? That means that there is zero loss of energy. What do we mean by perfectly elastic? That means that there is no loss of energy at all. Cool? All right. And the average kinetic energy of gas, it depends on absolute temperature only. Okay. So these were the postulates, but you just have to remember 4 or 5 of them. So just remember, everybody, that first of all, we considered that the gas volume is considered to be negligible when you are considering the whole volume of the container or the room. Yes. Then we said that the particle motion is actually in a zigzag manner. They are constantly moving. That is your Brownian motion. Then we said that particle collision. The particle collision is supposed to be, they're always moving in straight lines. They're always moving in straight lines. So what they do is they collide. They go in different direction. But once again, it is what? Once again, it is straight line. So they are coming. They hit. Then they move in a different direction. Again, straight line. So straight line, straight line, straight line, straight line. Wherever they go, it's always straight line. These are the things that you have to remember. And the particle energy is what? It is absolutely perfectly elastic. That means there is zero loss of energy. All right, everybody. Yes. Now, once you have understood all of these, and we have just spoken about speed of the gas molecules, right? And I told you that the molecules, all of them, they do not have the same speed, okay? If that is the case, then that means that what are the different speed? What do we have to do? What do we have to do? Again, let's take example from physics, everybody. In our younger classes, younger grades, we have learned that when we say that average speed, and I say that my average speed was today 80 km per hour. That doesn't mean that for the whole hour, I was driving my car at 80 km per hour only. At certain times it was 60, at certain times it was 80, certain times it was 50. What did I do? I added everything and then I said that this was my average speed. So very similarly, the speed of the gas molecules, right? The speed of gas molecules, everybody. The speed of gas molecules is basically, you can give it as average speed, everybody. You all know what is average speed, isn't it? You all know what is average speed. Then there is something called as most probable speed. What is this most probable speed, everyone? Yes, for example, I told you that some of the gas molecules, they're very slow. Some of them are very high. But out of, let's say, if there are 10 gas molecules, out of the 10 gas molecules, let's say that 7 of them are moving in almost the same speed. 7 of them are moving in almost the same speed. 2 of them are very slow. 1 of them is very high. So the most probable speed, if I have to say, I will talk about those 7, right? Those 7 which have almost the same speed, I will say that this probably is the most probable speed. Correct? And the third one is, everybody, root mean square. So what do? You find the mean. Then what do is you just square it, root over, square it. Okay, this is your root mean square speed. Okay, Manika, my name is Nabamita Bhattacharya, bacha. My name is Nabamita, but you can call me Nabamita Ma'am because that's what most of my younger students also used to call me. I used to previously teach 6 to 8, then I taught 9, 10th, and finally I'm in 11th and 12th standard. So my younger kids, they used to call me Nabamita Ma'am. So if you want to call me that, you can call me that. Okay. Then I told you that this molecular speed, You have to understand, everybody, if I increase the temperature, don't you think that the moment I increase the temperature, what will happen? The speed will also increase, because now they have more, now they have what? Now they have more energy. So they will start moving really fast, isn't it? They will start moving very fast. But if I have a very heavier molecule, it will not be able to move that fast. Correct? But if I have a lighter molecule, it will move very fast. So that means that the speed of the gas molecules, okay, it depends on, yes, depends on two factors, everybody. Depends on two factors. And what are the two factors, everybody? The two factors are, number one is mass, and number two, everybody, is your temperature. Based on these two factors, we actually we find out the speed of gas molecules. Is this much clear, everybody? Are you all able to understand whatever I have spoken to you? Are the postulates clear to you? Are the speed of gases, what are the factors that it depends on? Is everything, all of these clear to you all, everyone? If it is clear, then let me tell you that there is a formula that now you have to know. Guys, yes or no? I'm not able to see your chats. Yes or no? Yes, Nina is saying yes. Okay, great. All right. Now, here is a formula, okay, that is PV is equal to, about me. No? What was the meme? What was the meme? I haven't seen it. I'll check it later. What was the meme? Was there a meme on me? Arey, you all are very, very, very badmash. You all are very, very, very badmash. You guys. See, you lied to me, right? Anyway, all right. So here is a formula, everybody, okay? That you just have to remember it. I'm not going to let you know the derivation because you don't have to know. And it's just going to take a lot of time and you don't really have to know. Just remember the formula, because the formula is possibly important for you if you want to, be able to do the numericals, everybody. So 1 by 3, write down M capital N C square. Okay, how do you remember? So we normally know PV is equal to nRT, right? But here I'm saying that PV is equal to 1 by 3 MNC square. MNC, you know what is MNC? Multinational company. So remember it as this multinational company. And in multinational company, MNC, how many letters are there? There are 3 letters. So 1 divided by 3 MNC square. Now, you are going to ask me that what is C? C is the root mean square velocity. C is the root mean square velocity. C is the root mean square velocity. Yes. What is M? What is M? What is M? Particle mass. Particle mass. Okay. And what is N? N is your number of particles. Okay. No, Rakesh, you don't have to be. I was just kidding around with you. It's fine, it's fine. You don't have to feel sorry about it. I was having fun with you. It's okay. This is number of particles. Okay, guys, got it? Got it clear? Now that we have calculated this is from all of these postulates that we spoke about and all of that, okay? Now, in this case, you have to understand that the gas molecules, what they are doing is, I've just told you that they are always moving in straight lines. Remember, straight line, collision, straight line, collision, straight line, collision, straight line, collision, right? They are always moving in straight line. So, whenever something is moving in straight line, what is that? Translational energy, right? We're not talking about anything else. Translational, okay. So what is the translational here? What is the translational here? The translation kinetic energy will be, everybody knows what is kinetic energy, right? Half mc square, okay? All right. So that means, everybody, half mc square, right? Half mc square. That means that PV is equal to what? PV will be equal to, PV will be equal to, PV will be equal to this half mc square. If I put it here, n is number of particles, this is your kinetic energy, okay? It will be 2 by 3 kinetic energy. Yes, 2 by 3 kinetic energy. Am I right? And then what will happen is the kinetic energy will be 3 by 2 RT. 3 by 2 RT, or you can also write it as 3 by 2 KT, where this K, my dear student, is Boltzmann constant. This is your Boltzmann constant, okay, which is given to you as, this Boltzmann constant is given to you as, everybody, R divided by N A, that is gas constant divided by Avogadro number, okay, 3 by 2 nRT, exactly. All right, everyone. Now moving on, let's understand the different types of molecular velocities. Okay, let's understand the different types of molecular velocity. So remember, I just told you about the speed, that was average speed, most probable speed, and root mean square speed. The very similar way, speed is what? In physics, we initially learn about speed, but after some days, we start talking about velocity. So what is your average velocity, everybody? Average velocity, like I just told you, what is average velocity? Arithmetic mean of different velocities possessed by the molecules of a gas at a particular temperature. So at a particular temperature, how many ever molecules are there, you just find out the mean of it, and that will be your average velocity. Now, how do you write average velocity? You write it as U AV is equal to 8 RT divided by pi m, okay, and root over, okay. All right. Yes, this is your UAV. Now, what is most probable velocity? Most probable velocity is velocity possessed by the maximum number of molecules. Like I told you, the 7 molecules that were there, whatever is their speed, I will say that this is probably the speed of the molecules, right? So what is the UMP? UMP, that is most probable velocity, will be, everybody, 2RT divided by capital M. Am I right? Yes. Then what is RMS velocity? RMS is the square root of the mean of the square of speed of molecules. So that is, my dear students, 3RT divided by M. Correcto. That means that if I have to write down the ratio, everyone, let's write down the ratio, okay? So let's write down that UAV is to UMP is to URMS. Yes, that will be equal to what? What is UAV? UAV is 8 RT divided by pi m root over. Yes, is to 2RT divided by m. Yes, is to 3RT divided by m. Am I right? And this, from here, what I can do is, from here, if you are not able to see, I'll just move out. Yes. From here, I can take RT to be, I can cancel RT from everywhere. Yes, if I cancel RT from everywhere, then I can write this as root over 8 by pi. Yes, root over 8 by pi is to root 2 is to root 3. What do you think is the smallest one? Which one is the smallest one, everybody? We can clearly see that UMP. Yes, is it MP? Yeah, MP. MP is the smallest because root 2. Yes. And then if you calculate the values, everybody, right? If you calculate the values, that is the 8 by pi. 8 by pi will be around 1.128. That is to root 2. Root 2 can be taken as 1. If I take root 2 as 1, and then if you just calculate the values, you will be getting 1.128 is to 1 is to root 3 will be 1.224. 1.224. These are the values. And from here you can see that URMS is the is the greatest, and UMP, that the most probable velocity is the smallest. Yes, is this clear, everyone? Is this clear, guys? Everybody, right? Is this clear? Then we understand something called as collision frequency. Collision frequency is basically in a per unit time. Okay. You know what is frequency? What is frequency? The number of oscillations per second, right? Number of oscillations per second is called as frequency. So very similarly, what is collision frequency? Collision frequency is nothing but per unit time and per unit volume, the total number of collisions. The total number of collisions in per unit volume per unit time. So let me write that down. Collision frequency. What is collision frequency? Just told you, everybody. Yes, what is collision frequency? The total number of collisions per unit volume per unit time. Okay. Yes, understood, everybody? Nina, you are lost. Why are you lost? Chalo. Okay, getting back to it, everyone. Getting back to it. Chalo, this part you let it go, okay? This part was just extra. This part will only be required for JEE Advanced. As much as I am, as much as I know, this will probably be required for JEE Advanced. But after this, you know what is average speed? You know what is most probable speed? And you know what is root mean square speed. Am I right, Nina? Do you know that much? You know that much, isn't it? Tell me, bacha, you know that much? Yes? Okay. Now that you know this much, so speed and velocity are what? Velocity is something that we majorly want to talk about, because when direction is, when direction is involved, that's when we say that it is basically a speed with direction is velocity, isn't it? So basically, now we are not going to say speed, we are going to say velocity. Okay. So what is velocity? That similarly how we said that there are three different speeds: average speed, mean square speed, and that thing, and what RMS velocity, right? Yes. Sorry, RMS speed, right? We said these three kind of speed. Similarly, we wrote it down for velocity. Velocity, average velocity, most probable velocity, and root mean square velocity. Yes. Then what we did was, now I have told you certain values. So average velocity is equal to 8 RT divided by pi m root over. Most probable velocity is root over 2 RT by m. And RMS velocity is U RMS is equal to root over 3 RT by m. And then we can see that RT by m, RT by m, RT by m is common in all of these. So we have simplified it a little bit. When we simplified, we saw that U average becomes just 8 by pi, root over 8 by pi. Most probable velocity becomes root over 2, and root mean square velocity becomes root over 3. Understood this much? Once we have done that, and now when you calculate, try it out, no? Root over 8 by pi, or don't even do that. Let's take this root 2 is equal to 1. When we take root 2 is equal to 1, and then if we want to find the ratio, when you calculate, once you calculate, you will find these numbers, okay? What will you do? You will find these numbers, the ones that are written here, okay? So we have taken root 2 to 1, root 2 as 1. If I take root 2 as 1, that means, okay, all right. Wait a second. See, just doing the rough, everybody, okay? What do you have? Root over 8 by pi. What do you have? Root over 8 by pi is 2. Root over 2 is 2. Root over 3, right? What am I doing is root 2 divided by root 2. Yes. Root 8 by pi divided by root 2. Root 3 divided by root 2. Once you do this, when you do these, okay, when you do this, what do you get? You get these numbers. That 1.128 is to 1. is to 1.124. After looking at these data, these numbers, we said that actually, you know what, the most probable velocity is the least. Yes, the RMS velocity is the most and the average velocity is the second. Got it now? This much clear? Then we went to another term because we know that these gas molecules, they are not stagnant, right? They're not stationary. They're not at just one single point and thinking that, oh, come find me. No, they're not like that, right? They are always moving, constantly moving. And we also know that while they are showing you a zigzag motion, Brownian motion, they are also colliding with the wall. They are also colliding with each other. So now we want to find out that how many times are they colliding? Why are they banging on the wall? Why are they banging with each other? To find out that, you know, just like how in physics in class 10th, if you are in class 10th or in class 11th, you probably do know, right? What is frequency? What is frequency? Frequency is number of oscillations per second or number of anything per second. Very similarly, when we are saying that collision frequency, basically we want to find out in 1 minute how many collisions are happening, or in 1 second how many collisions are happening, or in 1 hour how many collisions are happening. So that is exactly what I am writing. The total number of collisions per unit volume, per unit time is your collision frequency. Got my point now? Is this clear? Now are you still lost? Yes? Anybody still lost? Or did you all understand what I'm saying? Everybody understood what I'm saying? This collision frequency is given to you as Z, and Z is equal to, please just note it down. You don't have to derive it right now. Note it down. Pi sigma square UAV, that is average velocity, okay, multiplied with n star square divided by root 2. Why root 2? Why root 2? That and all, don't ask me. Why root 2? Everybody, we have just, see, I have written here, you average. What is average velocity? Root 2 only, na? See, root 2, average velocity. Where is average velocity? No. Average velocity is not root 2. Most probable velocity is root 2. Most probable velocity is root 2. Actually, like I just told you, forget about it. Just learn this formula, okay? Just learn this formula, everybody. If we have to derive and everything, it will take a lot of time and we do not have so much time. Today, only the notification has already come. Okay, everybody, yes. So this is your formula. After that, what do you have? You have something called as Maxwell's distribution, okay? Now let's jump to something called as Maxwell's distribution, everybody. Maxwell's distribution curve. All right, guys, shall we go? Are we all ready? Are we all ready, guys? Yes or no? Same thing. Maxwell's distribution, Maxwell-Boltzmann distribution, everything, same thing. Yes. Okay. So Maxwell, he actually, again, I'm going to write it down and then I will show whatever is the data that is written. Okay. Let's do it here. Maxwell's or Maxwell-Boltzmann distribution curve. So Maxwell actually, you know what he did? He gave a curve, okay? There was a curve that he told us that the curve will look a little like this, in which what he has done is, in the x-axis, he has taken RMS velocity, that is root mean square velocity, and in the y-axis, he has taken fraction of molecules. What has he taken? He has taken fraction of molecules, okay? Just a second, let me draw the graph, then we will understand. Now, when he did this, yes, he figured that there was a graph like this. Okay, there was a graph like this. This peak point, you know what it shows? The significance of the peak point is actually UMP. Okay, what is it? The most probable speed. What is it? The most probable speed. Yes, most probable speed. Okay, all right. Then what is the area under the graph? The area under the curve, right? You must have seen in your mathematics. Yes, area under the graph. What is area under the graph? This graph, if I shade it like this, yes, what does it show? It shows total number of molecules. Okay, this shows total number of molecules. Now you must be asking that, ma'am, is the total number of molecules not changing? How is it going to change, everybody? You may increase the temperature. You increase the temperature, there is a possibility that the most probable velocity will change, or probably the velocity will only change. But hey, the number of molecules that are present in this gas, that is not going to change, right? That is not going to change. So area under the graph is giving you total number of molecules, and this is the graph. Now you know what he saw? He also saw that when every time, okay, every time he increased the temperature, let's say that this is T1. Now what he did was he decreased the temperature. When he decreased the temperature, do you know what happened? He saw that as you decrease the temperature, he saw that this is how the graph became. So the number of molecules still the same. But what happened to the most probable velocity? The most probable velocity decreased. See the RMS velocity. This side it is increasing, but this side it is decreasing, right? This side, when you go to the left, what is happening? It is decreasing. The velocity is decreasing. Then what he did was, he went a little further, he increased the temperature. When he increased the temperature, what he saw was, the graph became flatter. Now what happened is, see the velocity came forward. The velocity came a little forward. That means it has increased, and the peak, see, the peak went a little down. Yes. So that means from here we can understand that the most probable velocity increases when you increase the temperature. Okay. Yes. The most probable velocity increases when temperature increases. And that is exactly the graph that you see here, everyone. Tell me something. Are you able to see? Are you able to correlate? You getting the point? Yes. What the whole graph explains, everybody? Getting the significance or whatever this graph explained, everyone. Yes, I hope that you all have understood this. Yes, guys, is this clear? Is this clear? Do we all understand this? Do we all understand this? Yes, Rajendra has understood. Neena has understood. Everybody has understood? Okay. All right. So we have understood math. Acha. Oh, now they have, so the relation between is written properly here, which I have already explained to you, right? The same relation, see, that root 3, root 8 by pi and root 2, I have already explained this, but this is written here as well. So if you want, it's just basically given twice in your, in this slide, and you can just have a look at it, okay? All right, now we try to understand. So everybody, you have understand from the time we learnt about Charles' laws, Boyle's law, Avogadro law, and all of these yesterday also, right? Yes, yesterday also when we read about these things, we understood that there was something called as ideal gas. And what does ideal gases mean? Ideal gases, we meant to say that when all of these laws are followed, right? And then we read about kinetic theory of gases. What did the scientists do? They said that these are our postulates. If the gases, they follow these, that means that, the gases are supposed to follow these. But the gases were obviously not following. That's why I told you, but they are gases. Why will they follow? Right? They were not following. Correct. So they were real gases. Yes, they were real gases. Okay. Yes. Okay. Don't imitate. Don't imitate. Who am I imitating? Sri Krishna, what happened? What are you talking about? What are you saying suddenly? Hi, don't imitate. Who am I imitating? Okay. Anyway, so we see that the gases, what they are doing is they are definitely not following the behavior or the kinetic theory of gases. Yes, okay. Now, now, tell me something that why did the kinetic theory of gases fail? The kinetic theory of gases failed. If you check it out, what are the assumptions that we made? Remember the assumptions? We said that the gas molecules, they are negligible. How is that possible? Acha chalo, let's imagine that this is a huge room. Yeah, I can still understand, or I can still think that yeah, probably the number of molecules here are negligible. But what if I keep pressure, if I keep increasing the pressure, let's say if I keep increasing the pressure, and I bring it to very small amount. Yes, if I keep increasing the pressure, then will you still be able to say that yes, the volume is negligible? See, that was a mistake, right? That was a mistake, isn't it? Then we said that there are no interaction. Arey bhai, how will there be no interaction? When you bring them close, obviously the gases are like, why are you bringing close? I don't want to be close to each other, right? There will be repulsion. The repulsion will increase. So obviously there is definitely some interaction. So these are 2-3 mistakes that we made, not us, the scientists. These are 2-3 mistakes that the scientists made when they were writing kinetic theory of gases. And that's when we saw that PV is equal to nRT, that formula and all won't work. So we had to make some corrections. Yes, we had to make some corrections. So what did we do? We saw that, now please check it out everybody. Please check out this graph, okay, the first graph here. The first graph that you see here, you can clearly see that right here, the straight line, if you draw a graph for, this will be PV, I think. This is going to be PV and P. Pressure and pressure, so you can't draw, no? Yeah, PV and P. Correct it, okay? It's going to be PV. Alright? So when you draw a graph like this, what you see, this is your ideal gas. And these gases, do you see that they are going down, they're dipping. They are going below the ideal gas curve and then they are going up. Do you see that? Do you see that? So in this case, there are 2 types of deviation that is happening. The number one, when they're going up and up, this is called as positive deviation from ideal gas. This is called as positive deviation, everybody. And this part is called as the negative deviation, everyone. What is this called as? This is called as negative deviation, everybody. Are you seeing it? Yes? All right? Okay. Now, what did I say, everybody? See what is happening here. See what is happening here. Okay? At this point, acha chalo, no, not at this point. Let's talk about it in the next one. So you see a positive deviation and you see a negative deviation, right? Everybody, is this clear? Now, why is this positive deviation and negative deviation happening? I just told you that we had made mistakes when we wrote the kinetic theory of gases. Yes, when we wrote the kinetic theory of gases, we made some mistakes. And what were those mistakes? Molecular interactive forces do exist. Yes, molecular interactive forces do exist. And the particle sizes, okay, the particle sizes, you cannot say that it's infinite. There is finite size of particles. There is a finite size of particles. So this is the reason why this positive and negative deviation arise. Now, cut to the second graph. Yes, if you cut to the second graph, no, bacha, you will not be able to do that, because I am completely associated with Vedantu and the YouTube classes do take a lot of time and I also have to, take care of the whole channel and the team and everything. So I don't think I'll be able to do it. Very sorry. Yeah, very sorry. Chalo. Anyway, moving on, everybody, understand. Now, this graph is once again there in your NCERT as well. In your NCERT, you will see this graph. Now, see what is happening, okay? See what is happening. Check it out, everybody. Just a second. I need a darker color. Yeah. So everyone, if I draw a line here, okay, if I draw a line here like this, and then if I draw a line here, yes, what do you see? Yes, what are you going to see, everybody? You will see that the red part is the ideal gas, everyone. Yes, the red one is the ideal gas, and the blue one is the real gas. Okay, so you see that the ideal gas one is here, Vi, and the real gas volume is Vr. Cool. All right. So what do I mean here is, I want to say that when pressure is high, when pressure is high, my dear students, do you see that the real gas volume is more than ideal gas? The real gas volume is more than ideal gas. Do you see that, everybody? Yes. Why is that? That's because what is happening is, at high pressure, repulsion is dominant. Yes. At high pressure, the particles are moving away. The particles are repelling each other. And because they are repelling each other, the volume is increasing. Right? Yes. So that means repulsion is happening here. Extremely sorry, guys. There is some internet issues at my house because it has started to rain heavily in Bangalore, everyone. It has started to rain very, very, very heavily, or I guess charge went off. Oh, I'm so sorry. I'm so very sorry, guys. Yeah. My battery just went off. Guys, can we take a break for 5 minutes? Shall we take a break for 5 minutes, everybody? Yeah? Sai Krishna, ma'am, my second year syllabus completed. How to start revision? Second year syllabus has been completed. You want to start revision? First, start with your first year, because you know that from your first year, you will be getting at least, you will be getting around 40% in JEE, okay? You'll be getting 40% in JEE. Yes, Rajendra, we are broadcasting it from, from Bangalore, and it has just started to rain, everybody. That is weird. Oh, anyway, my laptop, my iPad is getting charged, but let me quickly connect, everybody. Let me quickly connect, let's just complete this part at least, and then we will provide you with a break, okay? Just a minute. Now you will be able to see, I guess. Yes. Everybody, are you able to see or not yet? Not yet, no? Huh. Now you can see? Extremely sorry. Yeah, extremely sorry. I was so engrossed in taking the session that I forgot to see that there was no charge on my iPad. Anyway, all right, yeah. So as I was telling, that when the pressure is very high, you get to see that the volume of the ideal gas is lesser, whereas the volume of the real gas is high. Why? Because repulsion is dominant here. What is happening? Here what is happening is repulsion is dominant. Okay. All right, everybody. Then in the next case, what do you see? In the next case, what do you see? Here what is happening? Repulsion is happening, everyone. Yes. Not able to continue. What to do? Now my pen does not have a charge. Let's see how much charge do I have. Why is this not getting connected? And now check it out. Now check it out, everybody. One more time. One more time. When the pressure, why don't you teach organic chemistry? Arey Baba, I will teach you. First, at least complete the basics of physical and inorganic. No, then only you'll be able to do organic. I don't know why are you guys so worried about organic? I told you, no, I will start. Also, I'm going home on 19th. I have to meet my parents. I haven't met my parents for one whole year. So I'm going to go home, and when I go home, I will not have this whole setup. And because I will not have whole setup, I'll be teaching from laptop with half and half of the, half and half of the screen. At that point of time, it will not be possible for me to teach you organic because it will not be fun, right? You will not have fun. So that is why I'm not starting. But once I come back, this month end, we will start with organic, okay? Yes. So this is what is happening here. Here, repulsion is more, okay? Repulsion is more here, okay? And then when pressure is low, everybody, just check it out, everybody. Pressure is low. When the pressure is low, check. Here, right here, everyone. Right here. Do you see what is happening here? Do you see what is happening? Right here, you get to see just the opposite of it. Yes, what do you see? You get to see just the opposite of it. That means you see that the real gas volume is lesser than the ideal gas. Okay, what do you see? You see that when pressure is low, what is happening is ideal gas volume is more than real gas, okay, is more than real gas. And why is that so? In this case, attraction is more, okay. In this case, attraction is more. Gotcha, everybody? This is clear, guys? Yes? This is clear? Right, everybody? Okay? All right? Yes? Okay. So this part is done. Now what is happening is, so I was just telling you, right, that why we saw this deviation. That's because the force of attraction between gaseous molecules are negligible. That is what we said in KTG. What is KTG? Kinetic theory of gases. That is something that you also learn in your KTG. KTG is where? Physics. Physics, you have a chapter, right? Kinetic theory, KTG, and thermodynamics we keep talking about. Exactly. We occupied by gas molecules is negligible, we said, and both the assumptions are not really a good idea, right? I mean, I cannot assume from my students that, yeah, you will all respect me. When I'm teaching on YouTube, I know very well that every single day there will be some students who will come and say something wrong about me, right? Yeah. So I cannot expect that all my students will be really good to me. I cannot expect that. But see, why? Because I assumed wrong. Correct? Very good. Exactly. Now, coming back to this, everybody, from this graph, you see that, from this graph, you saw that P ideal, the pressure, see. From this graph, do you see what is happening? Yes, the pressure of ideal gases will be slightly more than the real gases. Why? Because in the ideal gas scenario, we said that there is no interaction. And if there is no interaction, if nobody is holding me back, obviously I will run in the same speed and go and collide myself, right? I will go and bang myself on the wall, isn't it? But if I have interactions, if somebody is holding me and if I try to run, I will still be running at the same position, and maybe, just maybe, what will happen? My speed will also keep reducing. And as it keeps reducing, what will happen? What will happen? The attraction is more. So because of attraction, we see that the pressure in ideal gases is more, but the pressure in real gases is a little less because of this attraction, isn't it? Yes. Very good. So that means now we needed correction. And who gave the correction, everybody? The same old fellow, Van der Waal. Van der Waal said that I will give you correction. And how did he give the correction? He said that let's take that PR. PR is the pressure of real gas. Plus, he said that let's do N square A divided by V square. Okay? Yes? And then he said that let's write V minus NB is equal to nRT. Now you have to understand that this part is the what? This part is completely for ideal gas. Okay. And this part is the right here that you see, this is your volume correction he has done. Okay. What has he done? He has done volume correction. Okay. This is your volumes correction. Miss Patil, you will understand. You will understand, everybody. Don't worry. This is a correction that he has given. Okay. This is a correction he has given. Okay. All right. Now you just have to understand, nothing much. Don't worry about this n square and all. It will all go away. Chill, chill. What is this A and B, guys? This A and B. This A is actually the attractive force. This A is the attractive force that we were assuming it's not there. Okay. We were assuming that this A and all, this attractive force and all are not there. Why? Why did we assume? Because we said that, hey, ideal gases, there is no interaction. Right? We said that ideal gases have no interaction. So we had to bring in an attractive force. So this A is the attractive force and this B is actually the size or it is, what is it called as? Co-volume. It is also called as co-volume. You don't have to ask about all of these things. You don't have to learn about all of these things. Nobody will ask you in JEE. Just know that this A and B are actually, you know what? These are van der Waals constant. Okay, these are van der Waals constants. He gave this constant. He's like, you know what? Let's just add all of these. Okay, let's just add all of these. Now, everybody. Now, if I consider this n to be 1. If I consider that n is equal to 1, okay, let's just say that n is equal to 1. If n is equal to 1, then what will happen to this formula that I have written? If my n is equal to 1, that means that I will get something like P plus A by V square and then V minus B, isn't it? I will get this V minus B is equal to RT is equal to RT. Will I get something like this? Yes, I will get something like this. So that means that I can also write it as P is equal to RT divided by V minus B minus A by V square. Am I right? Can I write it like this? So this is also, after rearranging, you get this. Okay. After rearranging, you get this. Now, do you remember that sometime back I told you about collision frequency, right? Sometime back I told you about collision frequency, isn't it? Collision frequency. Now, forget about collision frequency. We're done with collision frequency. Now we have to read about compressibility factor. Okay, there is something called as compressibility factor. But before that, just look at this slide, everybody. Just look at this slide and tell me what are the things that you are able to understand from here. Because I have pretty much taught you everything that was related to van der Waals, everything that is related to the correction. Please let me know if you all are able to understand all of these. Is this clear, guys? Is this clear? Okay. These are basically everything that I've taught you. Chalo. Moving on, everyone. Now understand what are the features of A and B. Okay. The gas having higher value of A can be liquefied easily. Yes. The gas having higher value of A. Okay. Understand, everybody. Gas having higher value of A. What did I tell? What is A? A is the attractive force. A is the attractive force. So if a gas has higher value of A, that means there is more attraction. If there is more attraction and you increase the pressure, it will easily liquefy, isn't it? Because the moment you increase the pressure, the gas molecules, they come closer. If they come closer, they are liquefying. Correct? So if they have a higher value of A, they can be liquefied easily. And that is why hydrogen and helium are not liquefied easily. Do you know why? Because they don't have higher value of A. Are you clear? Understanding, everybody? Yes? Alright. What is the unit of A? The unit of A is liter square atm mole square. What is the unit of B? The unit of B is liter per mole. liter per mole. Okay. All right. Yes, everybody. Now, we spoke about that, while I said that A and B both are van der Waals constant, I also said that van der Waals constant of attraction A is actually greater than the van der Waals constant volume B. So that means that the values, the numerical values of A and B, they lie somewhere between 10 to the power minus 1 to 10 to the power minus 2 to 10 to the power minus 4. Okay, this is their numerical value. All right, are we understanding everything? Now we have to study something about compressibility factor. Yes, what is this compressibility factor, everybody? The compressibility factor is actually denoted by Z, okay? Yes, and that is, what was it? Observed molar volume. Yes, it is observed molar volume. Observed molar volume divided by ideal molar volume. Which means we know that PV is equal to nRT, right? Yes, and if n is equal to 1, if I again consider that n is equal to 1, that means what can I write? I can write PV by RT is equal to 1, which is nothing but a constant, and that, my dear student, is your Z, okay? This is your Z, everybody. Cool hai? Got it? Now you have to understand that if the value of Z is equal to 1, if the value of Z is equal to 1, that means that it is an ideal gas. Okay, that means that it is an ideal gas. But if the value of Z is greater than 1 or less than 1, then it is a real gas. Okay, all right, everybody, yes. So basically Z is equal to PV divided by nRT, which is something that is written here, as you can see. Yes, and from here only I have just derived this. Cool, everybody, got it clear? And I just then said that n is equal to 1. What if n is equal to 1? Yes? Yes, yes, aim God, absolutely right, absolutely right. That is exactly what I said, isn't it? Are you guys able to see it a little differently? No, everything is fine, right? Everything is fine, exactly. Okay. Now then here it is written that if Z is lesser than 1, that means that the gas is more compressible. Okay. That means that the gas is more compressible. If Z is greater than 1, that means that the gas is less compressible. And if the Z is equal to 1, that means that the gas is ideal, bachos. Okay, understood? So from here you can clearly see, right? Look at the graph. The straight line, the parallel one, that is parallel to the x-axis, that is your ideal gas, in which Z is equal to 1. If it is going up, that means that the gas is less compressible. And if it is negatively deviating, that means that the gas is more compressible. Now, shall we do a question, everybody? Enough of theory. Let's solve a question. What do you all say? Shall we solve a question? Shall we solve a question, everybody? Yes. Here is the question. The question says that, okay, do liquids have compressibility? Yes, but lesser than gases, definitely. Lesser than gases, definitely. Actually, we do not even count it. It's negligible. The compressibility is negligible. So, whenever we are calculating, we do not calculate it. Unless you are obviously in a very, very, very high standard, or you are doing your PhD and everything. Maybe then you will have to count it, but not otherwise. Not in your JEE mains and etc. like these exams, okay? Anyway, guys, so the volume of a gas A is twice than that of gas B. What is given? That is VA. Volume of A is twice of volume B. The compressibility factor of gas A is thrice than that of gas B. Okay. Compressibility factor ZA is equal to thrice of ZB, right? Yes. And the pressure of the gases are for equal number of moles are. So, moles are equal. So, Na is equal to Nb, right? And temperature at same temperature. So, Ta is equal to Tb. Am I right, everybody? Makes sense? Great. Now, what is the formula that we know? Formula we know is Z is equal to, let's write PAVA divided by NaRnTA is equal to, what do we know? Is equal to, what is the pressure? Pressure, okay. Pressure is PB, but volume is Volume is 2VB, right? 2VB. Volume is 2VB, na? Two VB, correct? And then NB and RTB. So that means that if I cancel, R and R will get cancelled. Acha, calculate this and tell me, guys. Oh, no. I have to add 3 here. I have to add 3 here because ZA is equal to thrice of ZB, right? ZA is equal to thrice of ZB, isn't it? ZA is equal to thrice of ZB. So from that, what will happen is, from that, ZA is equal to thrice B, 2VB here. Here also 2VB. Ah, very good. Yes, it will be 2PA is equal to 3PB. Option B. Option B is the correct answer. 2PA is equal to 3PB. Is that what you're getting? Is that, yes, aim God, you are absolutely right. 2PA is equal to 3PB. Yes. You guys are not able to see me, right? I think my internet is going on and off. Are you guys facing any issues while watching me? Is it buffering? Is it getting buffered, everyone? Or is it fine? Because I see that my OBS is running absolutely fine, but no buffering, na? Oh, then my phone is giving me trouble then. It's my phone that is giving me trouble. All right, guys. Now, finally, let's understand the deviation by van der Waals equation, okay? How is it deviating from van der Waals? See, if the pressure is very high, guys, if the pressure is very high, then what was our, correction? The correction value was, see, actually it was what? Actually it was, how did we write it? At a very high temperature, right? At a very high temperature, we know that it is, at a very high temperature, what will happen is, not temperature, sorry, pressure. No buffer and all, no? Okay, it's good. Cool. So, what was our formula? Our formula was P plus A by V square, right? P plus A by V square, V minus B is equal to RT, isn't it? Yes. Now, I'm saying that a very high temperature or fairly high temperature, like it's just a little high pressure. Why am I saying temperature when it's clearly written pressure? I don't know. Yes. So at fairly high pressure, what will happen is, I can say that P is so high. My P is so high that this almost becomes negligible. It doesn't matter. For example, if you have like 10,000 number, okay, let's say that if I have to spend 10 lakhs in a car, then how does 1,000 rupees matter? It doesn't matter. If I have to spend 10 lakhs, 1,000 rupees won't matter. Correct? So very similarly here, P is so high that A by V square, let's consider it to be negligible. If I consider this to be negligible, let's say that if this is nothing, then what will happen? My equation becomes P multiplied with V minus B is equal to RT. Am I right? Am I right, everybody? If that happens, then I can also write it as PV minus PB is equal to RT. Now, if I multiply both sides by RT or divide both sides by RT, both sides divide by RT, what will you get? What will you get? You will be getting PV by RT minus PB by RT is equal to RT by RT. So, it is equal to 1. Yes. So, that means what is my PV by RT? My PV by RT is equal to Z. Am I right? So, that means I can write that Z is equal to 1 plus PB by RT. And does this make sense, everybody, that at high pressure, the gas was deviating positively? Do you remember? Do you remember that at high pressure, see, at high pressure, Z was greater than 1? At high pressure, Z was greater than 1, and gas is less compressible right here. Everybody, do you remember? Do you remember? Yes, very good. Very good, everybody. So this we have understood, yes? This we have understood, isn't it? See, right here. Z is greater than 1, less compressible. Z is greater than 1, less compressible. See? Yes, absolutely right. Now, let's say that we're talking about moderate pressure. The pressure is not too high. The pressure is not too low also. Yes? Have a glass of water. Yes. How much time has it become? Is it about to be, it's about to be 2 hours, right? It's about to be 2 hours. I'm teaching you since the last 2 hours. Wow. Okay. Now what is happening at moderate pressure, right? We are saying that the pressure is not too high, the pressure is not too low also. If that is the case, then what will happen? My volume is large. But my volume is so large that the correction at the volume B becomes negligible. Yes, B becomes negligible. Correct. So once again, writing this formula, everybody, what was my formula? The formula was, everyone, if you can see, P plus A by V square, isn't it? And then V minus B is equal to RT. I'm saying my V is so large that B becomes negligible. And if that is the case, then what will happen? If that is the case, then what will happen is you will get P plus A by R square. Yes. And let's just write V here is equal to RT. Correct? Yes. That means it will become PV plus A R square V is equal to RT. Let's again divide everywhere. Okay. Let's divide RT. Let's divide the whole thing with RT. If I divide it by RT, then I will get PV by RT is equal to RT by RT will become 1. This RT by RT will become 1. So 1. And then this term, if it goes that side, it will become minus. So 1 minus AV by R square. No, not AV by R square. AV by R square, and here also we will have to write RT, isn't it? This will also be RT. This term, here also there will be RT. So, one second. Just a minute. AV by R square RT. Correct. So what I can do is this I'll have to cancel, and cancelling this, yeah, numericals also we will do. Wait, numericals I'm thinking I'll do a session tomorrow at 12 p.m. Tomorrow at 12 p.m. we will solve many JEE main PYQ. Today let's try to complete the session, right? Let's try to complete the session. So it will become 1 minus A by V capital RT. Correct? A by R square. Why did I write, Baba? That is why. Why am I writing R square? That's why I'm not able to figure it out. Aha. Wait a second, guys. Wait a second. Stupid mistake I have made. Very stupid mistake. This is V. This is V square. Okay. So it will become PV plus A by V it will become, because V square multiplied with V, right, is equal to RT. That's why I'm thinking. So PV by RT is equal to 1 minus AV RT. Okay. Yes. And this means that this is equal to Z. So Z is equal to 1 minus A by VRT. So that definitely Z is lesser than 1. If Z is lesser than 1, then what will happen, bacha? If Z is lesser than 1, that means we have learnt it right here. Look at the graph. If Z is lesser than 1, it is more compressible. Negative deviation. If Z is lesser than 1, negative deviation, so it will be more compressible. Got it clear, everybody? Now, what if the pressure is very low? What if right now the pressure is very low? If the pressure is very low, once again my volume becomes so large that I can again say that B is negligible, isn't it? I can again say that B is negligible. So writing the same formula, everybody, what will I have? I will have P plus A by V square multiplied with V minus B is equal to RT, right? Yes, but I can also write it as P plus A V square. Yes, and then here I can write it as V is equal to RT. Am I right? Yes. Arey, no, that's a recorded session. That is a recorded session, everybody. Okay. Now, if I divide by RT and let's multiply this, what will I get? I will be getting PV by RT plus, again, same thing. Yes, it will be A by V is, no, V is so large. My volume is so large that both this and this will become negligible. Okay. Both of these terms becomes negligible. If that happens, then what will happen? If both these terms becomes negligible, then it will be P plus P and then PV. PV is equal to RT. Now, if I multiply with RT, then it will become, now if I divide by RT, then what will happen? Then it will become PV divided by RT is equal to 1, which is nothing but equal to Z. Yes, correct, everybody? This is the term that you get at fairly low pressure. Yes, at fairly low pressure, you will be getting this. Okay, I think we are almost here, guys. We are almost here. Now, this has come in JEE Mains 2016. At very high pressure, the compressibility factor of 1 mole of a gas is given by, oh, come on, you can do this. At very high pressure, if the pressure is high, then what will happen to the compressibility factor? I think that everybody will know. Yes, everybody will know the compressibility factor of 1 mole of a gas is given by, at very high pressure. We have just done it, everybody. At very high pressure, see what happens? 1 plus PV by RT. That means that option A is the correct answer. Option A is the correct answer, everybody. Got it? Yes. Now, there are some critical factors that we actually have to study, but you can just remember the terms as it is. Okay. Critical temperature is TC is equal to 8A by 27 RB. Critical pressure is this. Critical volume is this. And the relation between critical temperature, critical volume and critical pressure is this. This PDF, I'll be anyway giving it to you, right? I'll be giving you the PDF. So just make a note of this. I mean, we don't have to go through the derivations. Just remember the values. Okay, just remember the values. All right. Yes. Now, here is one last question, and after that, I'm going to end the session, guys. I don't think I can take the session anymore. My back is killing me. Also, I have a session at 7 p.m. So, I want to be able to take the 7 p.m. session. So, I think let's end the session. Okay, I'll need at least half an hour to just rest a little bit and then come back. Okay. Yes, bacha, chemistry is the most scoring subject in JEE, but you can't do it. That means that you're not coming to my class. You have to come to my class. Chalo, read the question, everybody. Amongst helium, neon, argon and krypton, 1 gram of activated charcoal absorbs more of a krypton. Okay. Adsorption. Guys, what is adsorption? Does anybody know? Does anybody know what is adsorption? What is adsorption and what is absorption? Does anybody know what is the meaning of adsorption? Yes? Come on, guys. Any answers? Adsorption is basically when the atoms or the ions or the molecules, what they do is they come and get attached to the surface. Okay, adsorption is a surface phenomenon, if you remember. And you know what happens? Adsorption is directly proportional to, okay, let me write it down. Adsorption is directly proportional to van der Waal force. Okay, it is directly proportional to van der Waal attraction force. Yes, adsorption is directly proportional to attraction force. So that means that amongst helium, neon, argon and krypton, 1 gram of activated charcoal absorbs more of krypton. Okay, all right, got it, clear. Now it says that this is true, that amongst helium, neon, argon and krypton, 1 gram of activated charcoal absorbs more of krypton. Yes, assertion is true. Now the critical volume VC and critical pressure ATM is highest for krypton, but the compressibility factor at critical point ZC is lowest for krypton. No, yeah, that cannot be happening, because ZC is same for all real gases. Okay, ZC is same for all real gases, and that is 3/8. Okay. Funny Ram, what are you doing, bacha? There are so many strategy sessions. Just watch them, no? Just watch them. So that means that option A is correct. Read the question and see once. Read the question and see once. What did you understand or not? I just told you that adsorption is directly proportional to van der Waal attraction. So amongst helium, neon, argon and krypton, 1 gram of activated charcoal absorbs more of krypton. Okay? Yes? So that means that if it is absorbing more of krypton, that means that van der Waal attractive force is more. Okay. Then I said that, then the next one, the reason says that critical volume and critical pressure is highest for krypton, but the compressibility factor at critical point is lowest for krypton. That cannot happen, because ZC is equal to same for all real this thing. Okay, ZC is equal to 3/8 for all real gases. So option A makes sense. Okay, all right. Yes, are we done? Okay, with this note, everybody, I think I'll end the session now. All the rest of the questions I'll do it tomorrow at 12 p.m. Okay, everybody, let's write this down, everyone. Tomorrow at 12 p.m. everybody, I will take a session. Where is my note maker? Ha. Please write this down, everybody. What are my class timings? Somebody asked me, what are my class timings? So let me tell you, everyone, at 4 p.m., I do chapters. I take care of chapters. Yes. At 6 p.m., strategy, motivation, all of these. 7 p.m. every day, problem solving class. Problems, okay? And this is my timetable for Monday to Friday. Monday to Friday, this is my timetable. Saturdays, I keep changing, everybody. But tomorrow I will be taking a class at 12 p.m. problem solving of states of matter. Problems, states of matter, tomorrow at 12 p.m. to, I don't know, it might run till 2 or 3, okay? States of matter tomorrow, all right? And Sunday, you will again see some strategy sessions or something. And today, at 7 p.m., I'll see you all again, okay? 7 p.m., I'll meet you all again, everybody. 7 p.m., I'll be doing, today, what is the session, everyone? Does anybody know what is the session coming up today? Let me check. Oh, today is JEE Advanced. Yes, we are doing JEE Advanced 5 questions from states of matter. So be there at 7 p.m. also. I'll see you all at 7 p.m. We'll solve 5 questions from JEE Advanced, and that way we will also be able to gather 4 marks in JEE Advanced. So let's prepare ourselves for JEE Advanced as well. So with this note, everybody, thank you so much for being here. I really do love you all from the bottom of my heart, and thank you so much for staying tuned to this channel. Yes, I'll see you soon at 7 p.m. Don't forget to be there. Yes, it will benefit you, and also you know that today only on The Hindu. Yes, today itself in this newspaper, everybody that you know of. Let me show you guys. Let me show you everybody. So this is me live here. Don't forget to like the session. Thank you so much to all the students who have liked. I have also liked my session. Yes. And just click on this more part, guys. Do you see this more? Just click on this more. Once you click on this more, then this side here, what will happen is you will get to see a Telegram channel. This is the Telegram channel link. Okay. Just join the Telegram channel link and you will be able to get all the notes. I'll be sending you the PDF of this class notes in the Telegram channel. All right. Apart from that, what I wanted to tell you was today I came live, everybody, and there was a JEE main notification. What was the JEE main notification? In the Hindu, they have told that the exam date is going to, NTA will probably announce the exam date in November, and from December registrations will start. So do not miss out on a single day, my dear students. Keep coming for every single class and stay tuned for each and every problem class. I'll see you soon. Today, next session is at 7 p.m. right here. 7 p.m. States of matter. Do you see? States of matter, 7 p.m. Can you see this one? This one right here. Yes. 7 p.m. All right. Babu, what are you doing? What is this? Is so embarrassing. I already answered. I have told you. Why are you spamming like this, Baba? Funny, I have told you that I have made so many strategy sessions. Watch them, solve the problems. Keep coming for the problem solving sessions. You'll be able to do it. Chill a little bit. If you dance on my head, what more can I help you with? Huh? My goodness. Chalo guys, that was all for today. Tata bye-bye. I'll see you at 7 p.m. Don't miss it, okay? Bye.